Hello, Calculus 12 students. Mr. Yoon here again, and I'd like to take this time now and finish up the rest of the lesson here in this next video. And where I left off in the previous video, I did finish the left-hand approximation when I was given a table of values. And for the second question here, what I'm going to do is I want to use, I'm going to go ahead and try to use the right-hand method right now. So I know that I may have changed my order a little bit from what the problem was given. So let's just go back to the original question here. I'm going to use the right-hand method first. Okay, and then we'll go on. Okay, so let me use the right-hand method here first. And what I'm going to do first is I'm just going to label all my points here. I mean, I know this last point here, if I put this in black here, this is 10, 5. I know this point right here is going to be 9, 7. I know this point over here is going to be 6, 9. This point over here is going to be 3, 8. And this point right here is going to be 1, 6. And this point right here is going to be 0, 4. Okay. Now, if I want to make triangles that support the right-hand side, what we're going to do is you want to find one of your points and try to pick a point that's not on your y-axis. So if I look at this point right here in green, that's definitely not on the y-axis. All you have to do is move to the right. Sorry, move to the left now. So if you're doing a right-hand approximation, once you're at a point like this green point, just move to the left and construct a triangle. Okay. Now go to your next point, which is this point right here. Move to the right and then drop down for a triangle. Go to your next point, 6, 9. Move to the left, drop down. Go to your next point here, which is 9, 7. Move to the left, and this time connect to your next connect to the previous dot. Go to your next point, which is 10, 5. Move to the left and connect to your previous dot. And what you're doing is you're actually making these right-handed rectangles, and you have 5 of them, right? You have 1, 2, 3, 4, and 5. Okay, let me delete those, delete those, delete those, delete those, and delete those. Let's go ahead now and let's just try to approximate this first rectangle here in red. Okay, now what's the width there? Well, the width is 1, right? Because the width is 1 because I'm going from 0 to 1, so that has a width of 1. And what is my height? Well, my height is 6, right? This has a value of 6. So my height is going to be 6 for that first rectangle. What about my second rectangle? If I look at my second rectangle here in blue right here, well, what's my width? Well, I go from 3 to 1. So if I go from 3 to 1, my width will be 2, and my height here will be 8. Okay, so this height right here has a value of 8 right there. Okay, and so once again, this 8 right here is just this 8 over here. That 8 right there. Okay, now going to my next triangle, which is in red, which I'll highlight in red here. Okay, that has a width there of 3 because the difference between 6 and 3 is 3, and it has a height of 9. So 3 times 9. Plus the next triangle. If I look at this 9 and that 6, that means that that rectangle has a width of 3 again, and now we'll have a height of 7. And the last one will be, well, if I go from 9 to 10, that has a width of 1, and my height there will be 5. And if I approximate all of that, I get 75 units. Alright, now for my very final example here, I'm still using the same data, but let me go back and modify the problem one more time. Basically, I did a right-hand approximation method, and which is actually, I'll label that as 2. And for my last one, I'll use the trapezoid rule to kind of show you how the trapezoid rule works when you're given a table of values. Okay, so I think calculating the geometric shapes isn't too bad, but you definitely want to take some time and see if you can actually construct these geometric figures when you're given a table of values. Okay, so let me zoom in here. Okay, so once again, before I start this problem, what I'm going to do is I'm just going to label the points that were given to me in the original problem. This is 10, 5, the last point. The second last point was 9, 7. This point right here was 6, 9. This last point here is 3, 8. And the second to last point was 1, 6, and this is going to be 0, 4. Okay. Now, in order to kind of construct your trapezoids, you want to take maybe your second to last point, your second point here, and drop down, and connect that to the very first point and just draw yourself a trapezoid. All right. Then go to another point, which is another good point you can pick is 3, 8. You want to drop down, and then you want to just connect that to the previous dot to connect in order to form a trapezoid. And then move to the next dot, which is 6, 9. Drop down, and then connect to the previous dot to make a trapezoid. Then move on to 9, 7. From 9, 7, drop down, and then what you want to do is you want to connect to the previous point, which is 6, 9, and then do the same thing with the last one. 10, 5, drop down, and then just connect to the previous point, and there you have 5 different trapezoids. Okay. Now, if you want to calculate the trapezoid of this very first, for that very first trapezoid, remember the formula for trapezoid was h1 plus h2 divided by 2 times the base, right? That was the general formula. Now, if I apply that to the very first triangle, what is h1? Well, h1 is going to be 4, and h2 will be 6. So this is going to be 4 plus 6 divided by 2. And what's the base here? Well, the base is going to be the difference between 1 and 0, and that base will be 1. All right, so that is the area for my first trapezoid. And then if I look at my second trapezoid, which is this part in green, horizontal green, what is h1? Well, h1 is going to be 6, the y value there. And what is h2? Well, h2 is going to be 8. Divide by 2, and what's the base? Well, the base is the difference between 3 and 1, and so that has a base of 2. Plus the trapezoid for the next one here, this part in green. What is h1? Well, h1 is now going to be 8 plus h2, which is going to be 9. Divide by 2 times the base, which is going to be 3. So 6. The difference between 6 and 3 is 3. So 8 plus 9 times 3 divided by 2. And then I'm going to go ahead and just do the other trapezoids, because I think you guys probably see the patterns now. This is going to be has a base of 3 there, and finally the last one has an h1 height of 7 and an h2 height of 5 divided by 2 times a difference of 1. Once again, this 1 right here is the difference between 10 and 9. Okay, and if I go ahead and add up all those numbers, I get 74.5 units. Okay, and there you go. That's how you do a trapezoid approximation when you're given a table of values. All right, and that's it. Thank you very much.